Now we're going to look at two more methods for finding confidence intervals in sections 3.2 and 3.3. So a confidence interval, as we know, is a way to estimate the value of the population parameter. So remember that in general, we do not know the value of the parameter. It is unknown. And in chapters 1 and 2, we conducted hypothesis tests to gather evidence against the null hypothesis, and we determined whether the null or the alternative hypothesis was plausible. But that did not tell us what the value of the parameter is, and the confidence interval doesn't tell us the exact value, but it is an interval of plausible values for the parameter. Now that parameter could be pi if our variable is categorical, or mu if our variable is quantitative. Now there's a few different ways we can write a confidence interval, and we've written a couple of them so far. They've been in parentheses, separated by a comma, the left and right endpoints, so it looks like an ordered pair, but it's not. It's an interval of values. We can write the confidence interval as a statistic, which again is going to be either p hat or x bar, depending on the type of variable you have. Plus or minus, that's what this symbol here is, plus or minus, a multiplier times the standard deviation of the statistic. Now, the multiplier times the standard deviation of the statistic is called the margin of error. So those two things are the same. The multiplier, as it says below, depends on the confidence level, and we don't really need to worry too much about the multiplier. And then the standard deviation of the statistic, that is the standard deviation of the null distribution. And that has a new name now. We could call it the standard error and abbreviate that with SE. Now this third way of writing the interval is the way we've been doing it. The statistic minus the margin of error, that gives you the left endpoint. And then the statistic plus the margin of error gives you the right endpoint. And those are separated by a comma. So that's the way we've been writing the intervals so far. Now, it does mention here that the observed statistic is always at the midpoint of the confidence interval. So, for example, if I make an interval from 0.25 to 0.75, if that's my confidence interval, the midpoint is 0.5. That would be my statistic. Say it's p hat. Suppose this is an interval estimating pi. So whatever number is exactly in the middle of the left and right endpoints, that would be your statistic. Either a p hat if your variable is categorical, or a pi if your variable is quantitative. Now we have three methods for finding confidence intervals. The first one we already looked at in section 3.1, the plausible values method. So you can read through that as a summary of how we come up with the confidence interval if we use that method. But again, it reminds us that the confidence interval is an interval of plausible values for the parameter. And note to self, we only used the plausible values method with a categorical variable. What we're going to look at in this and in this handout is a 2SD method and also a theory-based method. So the 2SD method, note to self, can only be used if our confidence level is 95%. And if that's the case, then the multiplier is going to be 2. That's why it's called 2SD method. Now we have some formulas here depending on whether your variable is categorical or quantitative. And you have these standard error SE formulas on your formula sheet. And if you want to label them SE, you could. And this again is the standard deviation from the null distribution. Now it does say just above the table that if you have created a null distribution, you could use the standard deviation from the summary statistics and get the SD of the null distribution as a number right then and there. A lot of the times when we're finding a confidence interval, we haven't already conducted a hypothesis test, so we would not already have a null distribution. So if our variable is categorical, our confidence interval is the statistic, which is p hat, the sample proportion of successes, plus or minus the multiplier, that is 2, and this creates a 95% confidence interval. And then this square rooty thing, that is the standard deviation of the null distribution, also now called standard error. Now this looks similar to something we've seen in the past. We had on our formula sheet, and we have used before, the square root of pi times 1 minus pi over n, where pi came from the assumption in the null hypothesis. Now we're saying we could create one of these confidence intervals without actually having a null distribution or having any hypotheses, and in place of pi then from the null hypothesis we'd use p hat from the sample. If our variable is quantitative, the confidence interval is the statistic, x bar, plus or minus a multiplier, that would be 2 in this case, times the standard deviation of the null distribution, that is s over the square root of n. So just as a reminder, little s is the standard deviation of the sample. So here again, when the variable is quantitative, we have the potential to get confused because there are 2 standard deviations in the mix. One is s, the standard deviation of the sample, and the other is s over the square root of n, which is the standard deviation of the null distribution. So we have to keep in mind, when our variable is quantitative, there are 2 different standard deviations floating around. Okay, and then the third method, which we're going to look at kind of simultaneously with the second, is a theory-based method, and we only will ever use the computer to use the theory-based method. So they have different names depending on whether your variable is categorical or quantitative. There are validity conditions that must be met in order to use a theory-based method, and we're going to use the theory-based inference applet, and I will show you how to do that with these different examples that we're going to go over.